graphics, and how does it relate to UI? I tried to find a single image that represents motion graphics and UI together. This is the closest I could find. This is a screenshot from a blog by an artist who is working on the Iron Man movie. He's animating the Iron Man HUD in After Effects. The Iron Man HUD is one of the most beautiful examples of motion graphics. Unfortunately, it's not interactive. It is a pre-rendered movie. Also, there are at least 3 different UI technologies that you can see in the screenshot. There is Apple's Cocoa that is running the operating system. There's also After Effects, which uses a custom UI solution. And there is the HUD itself. The HUD is not interactive, but if it were, it would be a third set of technology needed to support it. And if you wanted to work on this, you would have to learn these different technologies. But that is a lot of technology to learn. We want to empower users to build something as beautiful as the Iron Man HUD, but we want it to be interactive. And we also want to use one UI technology for multiple purposes. We believe developers should only learn one technology. Here is the Unreal Editor. The Unreal Editor empowers users to create beautiful interactive experiences that rival cinema quality. And it is also capable of creating motion graphics. You can see there's some right there. But it should be much easier to achieve the desired look. And it should be easy to make beautiful motion graphics interactive in a meaningful way. How we plan to get there is what I want to talk about today. The good news is that the editor is already built using our custom UI system that we call Slate. And it provides a high degree of interactivity. So let's talk about Slate. Many features of Unreal Engine rely on the editor, so we had to build the editor first. Naturally, the UI system we built focused on the editor. And the editor is a large application. There are thousands of game developers using it daily. And this gives us confidence that Slate is a mature, robust system. It was a successful first step. But we always knew that we wanted to extend this technology to build beautiful, interactive motion graphics. So we made design choices that would allow this to happen. All UI in Slate is rendered on the GPU in real time, which means it will work on any platform supported by Unreal Engine. It also means that supporting animation and motion is not difficult. And using the GPU means that impressive special effects will be possible. Slate also has a lightning-fast layout system that can be used to arrange the UI at interactive speeds. This further helps dynamic UI creation. Slate already supports a variety of input methods besides keyboard and mouse. We have support for touch on mobile and controllers. We also have proven that Slate can be used to build complex interfaces with many intricate behaviors, like the ones you see in the editor. And it works for procedurally generated interfaces, and you can see those in the editor as well. So now we have to ask the question, what's next? We want to look at some user interfaces and motion graphics that are found out there that we aspire to build. And we want to ask the question, do we have the technology to build those? If not, what is missing? And what should we be adding? This is a screenshot from Iron Man, again. It is very beautiful. And there are many moving pieces in this screenshot. But none of them are interactive, and we want to build interactive UIs. However, this does set the visual bar. This is a screenshot from Hawken. You can see a more pragmatic take on a sci-fi UI here. The UI is still pretty, but real users have to be able to understand it and not be distracted by the unnecessary movement. So there are fewer unnecessary details. By the way, this is using Unreal Engine 3, and a lot of work for both programmers and artists working together had to be done in order to accomplish this UI. Here's a more recent screenshot of Hawken. There is even less clutter here, so it's even more usable, but unfortunately the beautiful motion graphics have been taken out. Here is a completely different kind of UI. This is an RPG UI. It is pretty animated in the game, but it resembles more a traditional UI. The ones that are found in the editor are pretty close. This also has many interactive pieces, and they're animated, and it empowers we want to empower you to build something like this as well. Finally, this is a screenshot from Fortnite. We've been using Slate to develop the UI for Fortnite, so we've gained a lot of experience about what works and what doesn't. So what's missing? Well, for one, Slate does not have a visual editor. It is wonderful for C++ programmers, but artists and designers should not have to learn C++. The layout system also requires you to think like a programmer, which can be difficult. And the visual tools for making animations are fairly limited at this point. Artists must work together with a programmer to animate something. Finally, sometimes it can be difficult to achieve the exact look that you want, because sometimes it's just not possible to draw quite the desired element in Slate. Or you may not be able to change the appearance of a button or a slider. So UMG is here to fix those problems. We plan this by building on top of the Slate runtime, because it is a proven runtime, and it delivers a high degree of interactivity. Our first step is to introduce a visual editor for Slate widgets. Controlling layout should be fun for artists and designers, as well as programmers. So we are going to add new layout tools. We are also going to add animation support that will be completely driven by artists or programmers, either. We will add better control over the look and feel of UI, better drawing methods, and once that fundamental work is complete, we can focus on fancier features like 3D support. So let's talk about what we've done already. We started in early May, so as you can imagine, we've only had a few months, and this progress is quite early in the process. This is what the UMG editor looks like today. The editor itself is written in Slate, and it generates Slate, so it's all one system. In the middle, you see the preview area. This shows you the UI that you have built so far. You can also select and modify parts of this UI. We call a single UI element a widget, and I will use that word quite frequently throughout the rest of the presentation. In the screenshot, you see that we have a text widget selected, and it says the word play. Over in the lower left, you see a structural view of the same UI. You can also see the currently selected element. The structural view is a different way to manipulate your UI, and it can come in handy depending on what type of task you're trying to achieve. On the right, you see the details panel. It shows you all the things that you can change about the currently selected widget. For example, the color can be changed. In the case of this widget, a text widget, we can change the font, we can change the font size, we can change the font itself, and we can also change the rules about where this widget should appear relative to other widgets on the screen. And also, we can change how the widget will respond to different inputs. On the bottom, you see a panel called Sequencer. This is a work in progress, but it already enables animation. Animation is achieved by changing properties of the widget over time. In this example, I'm changing the color of the text that says play, and I can even scrub the timeline. Here's what that looks like in motion. You can see the color of the text is changing as I scrub on the timeline. In the upper left, you see a collection of the various widgets that you can place. You can do that by dragging a widget into the preview area or into the structural view. Here's an example. The button currently doesn't have any text, but I have now dragged a text widget into the button. I will then change the text to say play. I will also change the font. Notice how the entire UI adjusted when I made changes to it. This is Slate's automatic layout system at work. I will play it again. You can see the UI adjusting. Slate's layout can be a powerful tool for building UIs that work at different devices with different shape screens. And it can also help you support different languages, because as text changes lengths and sizes, the layout can automatically adjust. Now I'd like to talk about composition, which is a fundamental principle in our UI system. In the previous video, I dragged a text widget into a button widget. This is called composition. It is the notion that any widget can contain any other widget. And I want to show you how it can be used. I started by placing just a single button in the middle of this example. Now I will place some text inside it. You've seen this before. And I'm going to change some properties. In this video, I could not find the text property when I selected the text widget, so I used the search feature of the details panel to find it, and just type in click me. What if I want to put a picture next to some text inside a button? In UMG and in Slate, there is no such thing as a special image and text button. Instead, we can use something called the horizontal box widget. A horizontal box arranges widgets next to each other. I will begin by dragging a horizontal box into the button, and then I will drag the text block into the horizontal box, followed by the image. We want the image to appear on the left, so I can select it and move it over. And then I want to tweak the visuals so that it is centered, and so that the padding makes the space between the elements look nice. I also want the image to look like a checkbox, so I will select it from my available library of images. All that's left is to tweak the pattern. Well, that's not quite right. That's too much. And that looks about like what I want. Now let's do a simple example where we will ask for the user's name. To do that, I can place an editable text box widget. But first, I'm going to change the text to say name. And then I will drag the editable text box into the horizontal box so that it appears in the right. I want the editable text box to be about 150 units wide. That is a hint for Slate's layout system to say, that's about how long the word that you will type in will be. But it can adjust dynamically. I also want to tweak the padding so that the text looks good. I will type in some temporary text and tweak the padding on that. With Slate, you needed a programmer to do all this, but with UMG, this can be done entirely by somebody with no knowledge of C++. Okay, I think we're done with that. Now I made a simple UI, and I want to see if it works. We are working on giving you the ability to test UIs right in the preview area. But this feature is not ready yet. So for now, I will use the blueprint system. I'm going to switch to my level editor, and I will select a trigger volume, which is a space that can react when a player walks into it. I will then go into the blueprint script for the level. Here, I'm going to place an event that will be triggered when a player walks into the trigger volume. When that happens, I want to create the widget that we've been working on. So I will select that and call it, the widget is demo1c. And I want to show it as well. So once it has been created, I will select show. This is all that we need to do. We can now go into the level editor and try playing. There is my character, and the widget has been created. I can type my name into it. This whole time, we've been building our UI inside a button, which is the power of composition. Now that doesn't really make sense to put a text box inside a button, but you can do it. And I want to demonstrate that this is actually working. So I can type in my name, but I can also click on it. This example may be silly, but composition is a very powerful idea. And we will combine it with layout to see what we can build. It is really useful when building up large UIs, this idea that a widget can contain any other widget. So now I would like to talk about the automatic layout system that we have. Unlike pre-rendered movies, interactive UIs must respond to change. For example, if a user resizes a window, the interface in that window has to rearrange itself to remain usable. That's why we do not say explicitly where the different widgets will appear. Instead, we specify a set of rules about where the widgets should appear relative to other widgets. The layout system then computes the best widget positions and sizes on the fly. The system makes localization easier. It also helps user interfaces work at different sizes and shapes. Let's see an example. When I resize this, you see some pretty conventional behavior. It is expected from most user interfaces. However, writing logic for doing this turns out to be pretty difficult. Accomplishing a behavior like this by setting up layout rules in Slate and UMG is much easier. Let's build some simple layouts. We're going to try to build this simple form. That doesn't sound hard, but we also want the layout to respond to changes in language. Let's start by making a title. We can do this by placing a border widget and then putting some text inside it. We also want the border to be blue, so we will select a blue appearance from our catalog. Now, we need to make room for all the user information. But first, we'll set the text and center the border. We'll make more room by using the wrap feature, which will put the border inside a vertical box. You've already seen the horizontal box, and the vertical box works much similar, except up and down. We want the bottom part to be gray, so we will select a gray appearance, and we'll set the text to be black. Let's take a moment to look at what we were trying to build. We're getting there. We now need to fill out the bottom part. Let's try doing that by using vertical and horizontal boxes. First, let's make a single row. We can do that by placing the text inside a horizontal box and then dropping down an editable text widget. And then, once we have changed its appearance to be what we want, we will wrap it in a vertical box and use copy-paste to make copies. Now I just copy and paste. We should also tweak the padding so that there is nice spacing between the elements. Being able to select multiple widgets at once is something we're working on right now. So that is about the look we're going for, and we can test it. That seems to work. We're pretty close. It seems that all we need to do is just change the text to say first name, last name, and title. When we do that, something unexpected happens. The UI does adjust, but it doesn't quite do it in the way we want. All the elements are appearing staggered, and we wanted everything to line up nicely. So perhaps the approach using vertical and horizontal boxes is not the best, and we need to try a different layout rule. I'm still going to use a vertical box to arrange the blue area on top of the user info. That part worked quite nicely. But for the user info, I will use a different widget called a uniform grid. In a uniform grid, every widget has a row and a column, and all widgets are the same size. Once we set the desired row and column information for every widget, they will appear in the correct spots. We can also tweak the alignment of the widgets so that they line up nicely. Here I am entering the row and column values, and you see the widgets are taking their spots. When a new widget is created into a uniform grid, it appears at 0, 0, which is the upper left corner. So you will see widgets sitting on top of each other. Notice that as the text changes, the grid responds in a way that we like, and all the elements can line up. This is just about what we wanted to achieve. Now we just need to update the row and columns for these new widgets and set their alignment accordingly. So we're almost done, but the semicolons don't line up, and now they do. Some padding would be nice, so that the space looks even. And we can set it uniformly on the entire uniform grid. Well, that looks pretty good. But initially, we set out to be able to test this in other languages. So let's see if the layout rules we chose respond to other languages the way we envisioned. UMG can make use of the same localization system that is used by the editor. And it is a powerful system that lets text change to the appropriate language very automatically, once the translators have translated it. But for now, I will just copy-paste some translations and see how the UI reacts. As you can see, the UI has adjusted to the shorter space required by these words, but now there's not enough space around the title, and we want to change that. We want more space on the left and right, and the vertical space looks fine. That's better. Now let's try a different language. We can see that the UI responded pretty well to this, so we've probably got a good set of rules to support rotation. We will support shear, and scale. Of course, transforms are much more effective when combined with animation and can create interesting effects, and UMG will support transforms and animation working together. Transforms, animation, and blueprints can give you even more power. Imagine you're building a login window. What if the user types in their email and password incorrectly? You might want to give them feedback, and if you use blueprints, you can trigger that feedback. It might look something like this. Transforms are useful even with static scenes. In this example, you see an artist has chosen to use a paper motif for their UI. Pieces of paper in real life are rarely arranged at 90-degree angles. They're never perfect, so the artist has chosen to rotate them. Inside the paper, you see text, and it is being arranged because it has to be dynamic for language changes and because the values can change. For example, the player could gain health or lose stamina. So, transforms have to work with layout as well. And in fact, they do work with automatic layout in UMG. Having a visual editor is great, but there's still one thing missing, and that is, how do you make your UIs interactive? There must be some way of telling a button what should happen when it is clicked, and some way of deciding what happens when the user drags a slider. Usually, that requires programming in C++, in C#, Java, or some other language. We believe designers should not have to write code. So, we've been building UMG to work with blueprints from the very beginning. Blueprints are a powerful visual scripting system in Unreal Engine 4. Blueprints give designers control over the UI. The visual editor can control the layout and the appearance, and blueprints can control how the UI responds to the user's actions. And this can be done without having to write a single line of code. Another feature we're working on is materials. Materials are a system that changes the appearance of things in Unreal Engine. And we can combine materials and widgets, as well as materials and blueprints. For an example, I would like to show you something simple that I've built. This is a radial display in the center of the screen. It's built from 3 parts. There is a text widget in the center. It is displaying, let's say, the amount of energy in the game. And there's an image widget around it. That is the semicircle. Above it, you see a slider. When the user drags the slider, I want the amount of energy to change. I have used blueprints to connect the slider to an energy variable. I created the energy variable in blueprints as well. And the text widget is going to read its text from the energy variable. The image widget has a material applied to it, which will respond to the amount of energy that we have. And this was built entirely without writing code. Let's see it in action. Here is the material that decides if each pixel should be black or white, depending on the energy level. But monochrome is a little boring, so I decided to add some color. Here, I've added a new part to the material. It looks at the amount of energy, and then performs a linear interpolation between red and green. The energy meter will now appear red when it is low, and green when it is full. Let's see that in action. Finally, when the energy is low, we want to get the player's attention because it is important for them to know the amount of energy. So I added a new section to the material to accomplish this. The highlighted section causes the energy to flash when it is below a certain amount, and as the amount of energy drops towards zero, the flashing will be faster. Here, I'm going to click on parts of the slider instead of dragging. As you can see, we have started flashing, and when the health is really low, we flash faster. So this is possible entirely without writing any code at all. Well, we've talked about a lot of things. We've talked about the power of the slate runtime and the widget library, as well as the automatic layout. We've talked about the visual editor, about blueprints, about animations, and about transforms. And we've talked about the ways all of these can interact to build a truly unique and interesting experience that is beautiful motion graphics that are interactive as well. And we're doing all of this using one set of technology so that once you have learned it, you can apply it everywhere. But we're not going to stop there. In the future, we would like to add more features. We would like to give designers more control over widget appearance. In fact, we'd like to give designers a way to apply widget appearances to large amounts of widgets systematically. We also want to improve the workflow over the control's appearance in other ways. And we want to add dynamic special effects. For example, blur or drop shadow. These are especially important when dealing with text because you cannot create an appropriate drop shadow for text by using tricks. Support for mobile and touch devices is already there, but we're working on making it even better. And once those features are done, we're looking forward to working on 3D UIs, which are a very fancy feature, but will ultimately let us achieve the kinds of things we set out to achieve. Once UMG is released, I look forward to seeing all the beautiful things that folks have made with it. Thank you very much.
진짜 꼼꼼하게 챙겨야겠다.
제일 중요한 건 한 일주일 배우면 네가 됐지.
그렇게
나왔을 때
그렇겠지. 심사와 모바일.
네, 이것으로 언리얼 3의 오전 시간을 모두 종료하고요.